I've got the graph open right now, and I'm noticing in late 2022, it massively spiked up. Was there something that happened there, like a growth in the infrastructure or something, or is that just a weird spike that you can't explain?
So I will need to check our journal of big changes, but I think basically we increased our capacity of crawling rather than. So it's not necessarily representative of increased production out there, but an increase in our crawling capacity essentially.
Yeah, I'm seeing like a few points in the graph where there's just like a sudden spike up between 1 month, where it's my assumption would be either crawling increase or infrastructure, some sort of infrastructure change that led to more code being added into it.
Correct.
Mm-hmm. So, how would I say? Is everything on GitHub to like a certain date covered, or how is that crawling handled? Are things prioritized in some way?
So there is no sophisticated prioritization right now. That might be something that we should add, but maybe we can get to that later. Mm-hmm. Right now, the way it works is that we have worked with GitHub, and we had good technical collaboration with them.
Well,
and essentially, GitHub already had basically an API to list all the repositories. So imagine you are starting cold, you start from that, and you archive all those repositories one by one. And when I say one by one, it's still subject to deduplication, right? So if we see 1 gazillion forks of the same repo, in general, it's stored only once, plus the few commits that are in one of the fork, but not in the main repo. Mm-hmm. But then there is also a feed of updates in GitHub. Essentially, you can get a list of repositories where associated to each repository, you also have an information that said when that repository was last modified, okay? And so that is essentially the key that we use for prioritizing sync. So there is no need to re-crawl a repository that has not been modified. So we only crawl the one that have been modified. Okay. Mm-hmm. And if you are curious, so on GitHub, like I guess in most public platforms, like I don't know the hard number, but like something like 90% of GitHub is dead in the sense that has not seen any change in the past, 5 years, 10 years.
Right,
okay.
Right.
So essentially the challenge there is just keeping up with the repository that do see changes, and you can ignore basically everything else.
Right, because a lot of people on GitHub will use the fork button as sort of like a repost kind of thing, where they're not actually forking the project, they're just sort of making their own clone of it.
Yeah, and then imagine how you usually use that. If you're a developer and want to submit a change to an existing repo, you do that, you do your fork, you make your change, and then your fork will, either it is deleted automatically when you merge your change, or it will remain there, stale forever, and there will be no need to archive it ever again, essentially.
Right. You mentioned they're not going back and checking things where there isn't a change. And this, I do think is actually like a really important to like hammer in, because we see obviously a lot of like open source infrastructure being hit by these like AI scrapers, right? And this is a problem. And you guys literally have like a thing to stop people just,
we are suffering from that problem too. So absolutely.
So it does make me happy to know that like you actually do care about that problem, and you're not just trying to create an archive of everything. Who cares what happens to the infrastructure? It's trying to do it in a way that isn't destructive to the rest of the ecosystem.
Yeah. Absolutely. So essentially, two cases. So let's separate the case of GitHub, because it's a huge infrastructure.
Sure, like the GNOME GitLab, the KDE GitLab, some random person's repo. Yeah.
Correct. And let's take a GitLab of a specific project from an open source foundation. So with GitHub itself, we're in touch with them. They know our bots. They recognize our GitHub accounts as bots, and they know they can scale, and so this is a kind of an easy case. But we are in touch with them, so they know we are there. We just didn't just start, archiving without being in touch with them. For the Forge, for the small Forge, is more interesting in the sense that we have a feature that is called Save Forge Now. Well, random users interested in the archival of a specific, say, GitLab instance can say, there is a GitLab there. There is a GitLab instance there. Can you please archive it? So when you receive that request, there is a manual process, a manual vetting process, in which essentially we reach out to the operators of that GitLab instance, and we actually ask them, well, we have received this request for archival. Are you okay with that? And basically, there is also a conversation in essentially the capacity. So essentially, if it is a small instance, they would not like having, I don't know, even 10 or 20 crawlers hammering them. And so they tell us maybe one crawler is enough, and so we crawl with only one. So that is the kind of process that we have in place to avoid essentially the risk that you mentioned.
Okay. No, that's yeah, that makes sense. Because I could imagine this with let's go with GitLab. GitHub. Sorry, I'm merging GitLab and GitHub in my head. GitHub. How many crawlers do you actually have going through that site? If you happen to even know the number.
So, I mean, our ops would know. I don't know the number off the top of my head, but I think it's in the ballpark of maybe 16, something like that.
Oh, okay.
So it's not hundreds. It's in the tens and not very high tens.
Okay. That was a lot less of a number than I expected.
Yeah, because I mean, really, the problem is not there. It's really they can scale. So essentially, we operate all the callers we can operate on our infrastructure, and that's enough, essentially.
Sure. Okay, fair enough. I guess.
And also, you mentioned the problem of AI scrapers, right? That I mentioned that we are suffering from as well. That's why you are seeing those checks when you navigate the archive. So those are very different kind of crawlers, right? So they come from usually residential IPs these days. So they are all different. They are hard to identify. So in our case, is a limited number of crawlers, all that identify themselves and that are known to the recipient of the crawling. So very different kind of workload.
So I guess if you happen to know, at what point did it really start to become a problem where that issue had to be dealt with crawlers sort of coming to this archive?
So for us, it's been essentially shortly before the release of some popular independent open LLM models, open weight models. And essentially, those were the sudden spike we noticed, but then it has become common. Right. So we are one of the targets, and so I guess maybe it's 2 years ago or something like that. So we will need to check the release dates, and I want to mention names, but that is essentially, it happened to us when it happened to everybody else.
Sure. Okay.
And frankly, I think we were not even necessarily targeted ourselves. There were just AI crawlers crawling the entire web, and so essentially finding us and going deep into the archive structure, which is very deep and creating all sort of load problems.
Right. And there is a lot on this site. So you can, if you want to have something that crawls constantly, it can crawl and will never find an end.
Yeah. And also, it's not the right way, right? So imagine that you want to have a copy of our archive of other resources out there. Crawling page by page is not the most efficient way to do that, right? So reach out and ask to be, a mirror operator or something. So it's just, that would be way more efficient and would reduce the burden for all people involved.